Okay, today's lesson I would like to talk about arcs and a sector of a circle, and as well as a segment of a circle. Alright, so when we have a circle, an arc is just part of the circumference. How do we find the length of arc? So for example, that's the center of the circle. That's a radii. And we know this angle theta is in radian. How do we find the length of arc? So how do we find this distance here? Alright, how do we find the distance here? Well, we know how to find the length of the whole circumference, which is 2 pi r or pi d. Then all we need to do is work out what is this angle here. And once we know this angle, we know the proportion, we know the ratio, and then we should be able to work out the length of an arc. Alright, so the length of an arc is equal to theta over 2 pi, because the entire whole revolution is 360 degrees, but in terms of radian is 2 pi. So theta over 2 pi and times by pi 2 pi r, because 2 pi r is the length of the whole circumference. So that is circumference. And theta over 2 pi gives you how, the size, right? How big or how small the arc is. Alright, now when you use the algebra, you can simplify this, right? The denominator is 2 pi times by 2 pi r. This 2 pi cancels out. It cancels out. And you get theta r. And that becomes the length of an arc. Alright, so the length of the arc is just equal to the angle in radian times by the radius. So for example, if we have a circle that's a unit circle, which means the radius is equal to 1, then the length of an arc is just equal to the angle, alright, the sector angle, which is this angle here, the sector angle in radian, alright, if it's a unit circle. So that's r, and that's the length of arc. Okay, that's the first formula. Now, second one, how do we find the area of a sector? It's the same thing, right? Very, very similar to the length of arc, but this time we're finding the area of this region here. And that's a sector. How do we find the area of that sector? Well, we're using exactly the same way to derive the formula. The reason for that is this is still equal to theta over 2 pi. We only need to change this part of the formula. Instead of finding the length of a circumference, we just need to know how to find the entire area of a circle. Alright, and we should be able to get another formula. So area of a sector is equal to theta over 2 pi times by pi r squared. Now pi r squared this time is the area of this entire circle. Alright, area of the circle. And if we multiply by theta over 2 pi, that gives you the area of a sector. So once we simplify this, right, that area of a sector is equal to half. Now you can cancel the pi and pi there. So that gives you half theta r squared. Half theta r squared. That's how we find the area of a sector. Right, so the last one is how do we find the area of a segment? Alright, so the question is, what is a segment? Alright, a segment is a region inside a circle that's bounded by a chord and an arc. So a segment, that's the chord here. A segment will be the area or the region in between of chord and an arc. So that's a segment. How do we find the area of this segment? Well, in order for to find the area of a segment, you need to find the area of a sector. Once you know the area of a sector, a segment is a part of a sector, you just need to work out how to find the area of the triangle. Once you know the area of a triangle, do the subtraction, you should be able to work out the answer. Alright, so the area of a segment is equal to area of a sector minus area of the triangle. Alright, so area of a sector we know that's equal to half theta r squared, which is the formula here. What is the area of the triangle? Now we have learned that if we know that's SAS, side angle side, if we're given this kind of information, then we can use the sine formula to find the area of a circle. And that's half AB, which is r times by r, and that's r squared, sine theta. Remember the both theta here are in terms of the radian, okay? That's not degree, but radian measure. That is how to find the area of a segment. All right, so these are the three formulas that you need to remember to do certain questions. Okay, let's do a question. Example 1. We've got a circle. Here's the center of the circle. All right. That's 90 degrees. Okay, all right. How about the first question? I'll give you an easy one first, right? To start with, right? Not something that's really hard to do. Okay, what about this question here? If we know this angle is equal to 120 degrees, and then we know the radius is equal to 5 centimeters. All right, the question asks us to find the area of the arc, which is this arc here. Okay, I will call this A, that's B, that's O. So the first one is find or calculate, all right, the length of arc. Length for arc AB. All right. So that's the first question. Find or calculate the length of arc AB, given this information. All right, now here comes a very interesting question. I didn't give you theta in terms of degree. I'll give you, in terms of radian, I'll give you the theta in terms of degree. So can we do it using degree? Yes, you can. You can still do it using degree. So for example, theta becomes 120 divided by, instead of 2 pi, you can divide this number by 360. And then you times by 2 pi r, you get the answer. Now, if you want to do it the other way, you can actually change that degree into radian first before you apply the formula. It's really up to you. But the most important thing is, please do not use this formula, all right, if theta is in degree. You need to change it. All right, so length of arc is equal to theta times by r. We know theta here is equal to 120 degrees. I would like to change that into radian. How do I change it? Well, 120 divided by 180 and pi. So now you can simplify these. That becomes 2 over 3 or 2 pi over 3. Okay, so 2 pi over 3 is the angle in radian. So once you got that, you can do the substitution, 2 pi over 3 times by the radius, which is equal to 5. So now, really easy, you get your answer. That's 10 pi over 3. Very simple. All right, very, very simple, straightforward. Okay, so the next question here is calculate the area of sector AOB. So how do we calculate the area of a sector AOB? Well, same thing, use that formula here. Area is equal to half theta r squared. And that gives you half times by theta, and we know theta is equal to 2 pi over 3, and times by r squared. Radius is equal to 5, so r squared is 25. So that becomes 50 pi over 6, or that's just equal to 25 pi over 3. Okay, straightforward, really easy to understand how to do the question here. Very simple. Okay. All right, so this is just the first question here. I'd like to show you another one, which probably slightly harder than this question. Maybe find a good question for us to do. All right, that's a good one. All right, example 2. We've got a circle. Okay, and that's equal to 6 centimeters as the radius. The angle here is equal to pi over 3. And the question asks you to work out what is this area. All right, the area of the segment. So let's call this as A, B, and O. And okay, and you need to calculate the area of this segment. All right, so how do we do this question here? Well, the area of a segment. In order for you to find the area of a segment, we need to find the area of a sector, and then we subtract the area of the triangle here. That's pi on 3, which is 60 degrees. 60 degrees isosceles triangle makes equilateral triangle, right, with all 3 sides equal to 6. All right, so let's start to do it. Area is equal to, we need to think about it, it's area of a sector, right, which is half theta r squared minus the area of the triangle, half r squared sine theta, and that is the formula to use. All right, so that gives you half times by theta, and theta is equal to pi on 3, r squared is equal to 36 minus half times by r squared again, so that's 36 again, times by sine 60, all right, or sine pi on 3. All right, so that's all. Just one simple formula, you do all the substitution, you get your answer. All right, so simplify this one here, that gives you 6 pi minus, that's 18, times by sine 60 is root 3 over 2. So the final answer will be 6 pi minus 9 square root of 3 square units. That's the area of the segment. Okay, still very, very easy to work out the answer here. All right, very easy. So that's example 2. All right, let me find another example to do. Okay, all right. All right, so the last example of this exercise will be this one here. All right, really interesting example. So like everyone, let's just make sure you look at it carefully. All right, so I need to draw a diagram first. Okay, all right, so now, it's not a very nice diagram, but I hope that it really gives you some idea. Have a look what's inside. We've got 3 circles with equal area. They're exactly the same circles, right? And then you can see there's a shape that created inside. All right, a shape that created inside. Your job is to find the area of that shape. Or like, how do we find the area of that shapes here? All right, so the shape looks like this. Okay, that is the shape. Each of these is just part of the circle. All right, they're all equal circles. Each of this arc is just part of the circles, and you need to find the area of this shape. All right, I do need to give you more information about the diagrams here, otherwise you can't do it. So those are the center of each circle. Okay, so all of those points are the center of the circle. What else you need to do this question? I think I also need to give you a midpoint here, right in the middle, and I need to tell you what's the distance of the radius. All right, so the radius of every circle here is equal to, let's just make that 4 centimeters. They're all 4 centimeters, and then you draw 3 circles, and then the question asks you to find what is the area here. All right, what is the area here? How do we do it? Okay, I need to give you more information, otherwise you can't do it. All right, if I connect all these 3 points together, let me tell you the triangle here is an equilateral triangle, which means that's 60 degrees each. All right, with that information, you should be able to work out the answer. Okay, how do we do it? All right, let's just focus on this diagram here. Well, now the radius is equal to 4. We know this is just part of the circle here. To do this question, you do need to break that into two, all right, smaller parts. If you look at that question, basically, you're finding the area of that segment. All right, you're finding the area of that segment. You times by 3, because you've got 1, 2, and 3, 3 equal segments. And then you plus the triangle in the middle. That's all you have to do. We know the radius is equal to 4, so that's 4, that's 4, that's 4. You should be able to find the area of the triangle, because that's 60 degrees or pi on 3. Alright, so once you know that, it's very similar to the question that we did before, like this one here. Very, very similar. Alright, just the idea like behind how do we think about it. Alright, so how about let's find the area of the segment first, alright? The area of one segment. So the area of the segment is equal to 3 times brackets. Now we need to find the area of one segment, which is equal to the area of a sector, that's half theta r squared, minus the area of the triangle, half r squared sine theta. So that gives you 3 times pi on 6, pi on 3, times by r squared. Alright, r is equal to 4, so it's 16. Alright, so let's just keep doing this. Alright, after you simplify it, that becomes 8 pi over 3 minus 8 times by square root of 3 over 2. Alright, so if you times everything inside, that becomes 8 pi minus 12 square root of 3. Okay, here is the answer, right? That is the answer for the area of 3 segments. The 1, 2, and 3. 3 segments. Alright, we still haven't finished the question because we need to find the area of the triangles inside. But we know how to find the area of triangle. It's just this part. That is the area of the triangle. So area of the triangle is equal to half r squared sine theta, which gives you half times by 16 times by sine pi on 3. And that's 8 times by square root of 3 over 2, which is 4 square root of 3. Alright, 4 square root of 3. Alright, that's all. We've got area of a triangle. We've got the area of 3 segments. Now you want to find this entire area. We simply combine this together. So the final area is equal to 4 square root of 3 plus 8 pi minus 12 square root of 3. And the final answer will be 8 pi minus 8 square root of 3. And that's how you find the answer for this question here. Alright, thank you everyone. I hope you enjoyed the lesson. This is how we find the area of a sector, the length of an arc, and the area of a segment. Thank you.